Buoyancy and flotation. Objective. In this video, we will learn about buoyancy and flotation and also about stability of floating bodies. Buoyancy. When a body is either wholly or partially immersed in a fluid, a lift is generated due to the net vertical component of hydrostatic pressure forces experienced by the body. This lift is called the buoyant force and the phenomenon is called buoyancy. Let us see how a hot air balloon floats. As the hot air rises from the burner, heated air molecules spread out or expand and bounce around, and the space becomes less dense than the surrounding space. In practical, there are only three gases for lifting a balloon. They are hydrogen, helium, and hot air. Each is much less dense than ordinary air, and this gives them their buoyancy. In this case of hot air balloon, increasing the air temperature inside the balloon envelope makes it less dense than the air, thus making it lighter than air. The amount of lift depends on the difference between the temperature inside and outside of the envelope and the weight that is being lifted. Flotation. It is associated with floating and submerged body. Based on submergence, we have fully floating body, partially submerged body, fully submerged body. In case of fully floating body, if the weight of the body is very less when compared to the buoyancy force, then the body will completely float. In case of partial submergence, the downward weight of the body is equal to the buoyancy force, which is the weight of volume displaced. And in case of fully submergence, if the weight of the body is very large when compared to the buoyancy force, then the body will submerge fully. Buoyant force F equals to weight of fluid displaced. Stability of floating bodies. In case of floating body, when it was in equilibrium, the downward weight W acting through center of gravity of the body is counterbalanced by uplift force of buoyancy acting through center of buoyancy. It is the point which the buoyant force acts, and the center of buoyancy is center of displaced fluid. Metacentric height. It is a measurement of the initial static stability of a floating body. For a floating body, when metacenter is above the center of gravity, then the body is said to be in stable equilibrium. And when the metacenter is below the center of gravity, then the body is said to be in unstable equilibrium. And also, when the metacenter coincides the center of gravity, then it is said to be in a state of neutral equilibrium. Let us look at an example. A large iceberg floating in sea water is of cubical shape. Specific gravity is 0.8. If 30 centimeters proportion of the iceberg is above the sea surface, determine the volume of the iceberg and buoyant force. If specific gravity of sea water is 1.025. Solution. Let the site of the cubical iceberg be h. Total volume of the iceberg equals to h cube. volume of the submerged portion equals to h minus 30 into h square. Now, for flotation, weight of the iceberg equals to weight of the displaced water. That equals to h cube into 0.8 into W equals to h minus 30 into h square into 1.025 into W. H equals to 137.14 centimeters. The side of the iceberg is 137.14 centimeters. Thus, the volume of the iceberg is 2.57 meter cube. We knew that buoyant force F equals to rho GV. Specific gravity of seawater equals to density of seawater by density of water. On solving, we get density of seawater equals to 1025 kilograms per meter cube. Now, we calculate for buoyant force, which equals to 25,841.9 newtons. Hence, the buoyant force on the iceberg has been calculated. Summary. In this video, we have learnt about buoyancy and flotation.